All right, have a look up at the board right now. We had due yesterday 2 questions from your constant velocity worksheet, question 5 and 6. Please take a look at the answers there, and then let me know if we need to go over either or both of those questions. What would they be in meters per second? Good question. I'll figure that out for you. All right, there's our answers in meters per second for those of you who did it in meters per second. I did it in kilometers per hour simply because we had the numbers given to us in kilometers and minutes. If I went meters per second, then that required me to do 2 conversions, right? Kilometers to meters and minutes to seconds. But that's okay. There's absolutely nothing wrong with that. In fact, I would say if you're not sure, that's what you should do, right? If you're not sure what units to use, then use meters per second. Okay, kilometers per hour works in this case, and it is a little bit easier. There's only 1 conversion to do, but it's okay to do a little bit of extra work and get meters per second there, right? I suspect we're going to have to go over number 6. Anybody for number 5? No? No? All right. Number 6 it is then. Number 6 says a car travels 90 kilometers per hour east for 10 minutes, then 100 kilometers per hour west for 30 minutes. What's the average speed and velocity? So what we want to do here, what people tend to want to do incorrectly, is say, look, the first displacement is 90 kilometers to the east. It's not. It's not 90 kilometers to the east. It says it's traveling at 90 kilometers per hour to the east for 10 minutes, then at 100 kilometers per hour for 30 minutes. What we need to do is still break it up into 2 sections, just like we have a number of questions that we've done now. Break it up into 2 sections. It's doing this, then it's doing that. Okay, let's do this first. Let's do stage 1 first. The velocity in stage 1 is 90.0 kilometers per hour if we define east as positive. The time here is 10 minutes, which I converted that to hours. I get 0.1667 hours. In stage 2, the velocity was 100 kilometers per hour, but it was west, so we're going to make a negative. The time was 30 minutes, and that's a nice easy conversion to hours there. I got 0.500 hours. Okay, what we've done in the questions to this point is said, okay, look, V equals d over t, the total displacement over the total time. And that still applies here. The only problem is we don't know the displacement in either stage, so we got to find it. Let's take this equation, rearrange it for delta d. The t goes up by multiplying, it becomes v times t. Let's do that in both stages here. The velocity in the first stage is 90 kilometers per hour. The time in the first stage is 0.1667. We do the math there, and it works out to be 15 kilometers to the east. In the second stage, we got to get the displacement as well. It's also v times t. It's negative 100 times 0.500, which gives us negative 50 kilometers. Now, right now, we're just at the point where we are when we start most questions. We've got the displacement in each stage, right? But we have to go that 1 step further and find the overall average velocity. Or we'll go average speed first. Distance over time. The distance here is what? How far does this car travel? I don't care about direction because speed's a scalar, right? Distance is a scalar. How far does it travel? Derek, how far does this car travel? Good, 65 kilometers. And what about the time here? Nice easy time here, right? 0.5 hours plus 0.167, 0.6667. No. Yeah, that's right. Divide that here. We get 97 kilometers per hour. 65 kilometers because distance is a scalar. It doesn't matter whether we get east and west or east and east. But when we go to do velocity, it does matter. For velocity, we need displacement over the time. And the displacement here would be what? 15 kilometers to the east, 50 kilometers to the west. The displacement is what? Jared, what's the displacement here? 50 kilometers to the west, neg 50. 15 to the east. Good. 35 to the west. So we're going to make it negative 35 divided by the time of 0.667 hours. We do the math there, it works out to be negative 52 kilometers per hour. And the negative 52 means the velocity is to the west. So, answer this question for me, please. I've asked this a number of times, and you guys get it every single time, so that's great. See if you get it again. Oftentimes, speed and velocity have the same number. They don't here. Why not? Why are the speed and the velocity two different numbers? Okay? Right, we switched direction. Midstream, we changed from east to west. If we go east, then east, those two numbers will be the same. One of them will have a direction, one of them won't, but the numbers will be the same. If we go from east to west, then the numbers are going to be different. Okay? All right, the last thing that I asked you to do last night, and I think that everybody finished this up in class or scheduled help yesterday, was your position versus time worksheet. I want to give you the answers for question 2 and 3 on your position time worksheet. And then we'll go over at least one of those two questions, okay? Here's our answers. We want to go over at least one of those two questions just to refresh your memory as to how we do things. If we need to go over both of them, that's fine as well. Which one would you prefer to go over here? 2? Okay. Does anybody need number 3 gone over, or are we okay with that if we go over number 2? Okay, 2 it is. Remember, there's a number of things that we can find on a position time graph. One of them is position. Anytime you want to find something that appears on the y-axis, it's just going to be going up and over. But in this question, you look at it, we're not actually asked for position here. So it starts a little bit harder here. Position is up and over. How do we define displacement? That's how we're going to determine how we're going to get displacement from this graph. How do we define it? Allie, how do we define displacement again? Yeah, the change in position. Good. Yeah, close enough. The change in position. So we want to find displacement here between 0 and 10 seconds. Position is up and over. So we're going to do that twice. Up and over, then subtract them. That's going to give us displacement here. Okay? The position at 0 seconds is, well, there's nowhere really to go over there. 14 meters. The final position at 10 seconds is 0 meters. 0 minus 14 equals negative 14 meters. Now, east-west, oh no, okay, 14 meters in the negative direction, whatever we define positive as. The displacement between 10 and 18 seconds. Well, here, the initial position at 10 seconds is 0. The final position is 6 meters. So we're going to say 6 minus 0 equals 6 meters. Third question, C, the average velocity between 0 and 10 seconds. Well, there's two ways to do average velocity when you've got a straight line here. And that's what we've got, right? Between 0 and 10 seconds, it's a straight line. What's one of them? Yep. The slope, right, rise over run. What's the other way when you have a straight line? Okay. Yeah, delta D over delta T. For this one, let's do slope. Okay? Slope is equal to rise over run. What's the rise from 0 to 10 seconds? Well, there's not really a rise, right? It's more of a fall. Right? What's the fall? Negative 14 meters, right? We just figured that out. Okay, from here to here on the y-axis is negative 14 meters. The run from 0 to 10 seconds is 10 seconds. Gives me negative 1.4 meters per second. Now, question D, similar question, but this time we're asked for the average velocity between 10 and 18. This time, we're not going to use the slope equation. This time, we're going to use the other one. Okay, V equals delta D over delta T. Although it ends up being the same thing. Delta D between 10 and 18 seconds is 6 meters. Delta t is 8 seconds. So 6 is delta d. It's the same as the rise. 8 is delta t. That's the same as the run. 0.75 meters per second. Now, question E. Here's the toughest one on this page, I think, question E. What's the average velocity between 0 and 18 seconds? Why can we not use the slope equation here? Why can we not use the slope equation to find the average velocity between 0 and 18 seconds? Yep. Right. It's not a constant speed. It's not a straight line. There's two straight lines. In question number 4, there's a curved line. When it's not a single straight line, you can't use the slope equation. But what you can do is still use v is equal to delta d over delta t. What is the displacement between 0 and 18 seconds? Well, the final position there at 18 seconds is 6. The initial was 14. The time between 0 and 18 is 18. 6 minus 14 is negative 8, divided by 18. I think that works out to be 4 over 9, 0.44. Is that right? Negative 0.44 meters per second. How many people got that one particularly? E. Good. Excellent. Okay, that's a bit of a tricky question. And you guys passed the test on that. All right. Any questions on any of this stuff? All right. Tomorrow, we'll have ourselves a little quiz on position time graphs. That's it. Just a little quiz on position time graphs. What'll probably happen is I'll give you one question, like 1, 2, 3, or 4 on that worksheet. And if you can do that question, you'll get 100, just like many of you did on your last quiz that you wrote yesterday.